What makes evolution true? That's what we're going to be talking about tonight. And you have the opportunity, if you want, to join the stream and tell me what makes evolution true. A lot of times people are saying evolution is a fact. There's a huge amount of evidence for it. And yeah, I don't know what number I'm on with these streams. It's quite a few. And so far, the only evidence that has been brought for evolution is Science Rules brought whale pseudogenes. Erica brought from Gutsick Gibbon brought the prediction of ape transitional features, which we found. Dr. Dan brought a mutation that doesn't cause sickness, but protects against malaria. That's the sickle cell gene that doesn't, or mutation that doesn't cause sickness. Grayson brought the prediction of transitional reptile bird features, Archaeopteryx, and we found Archaeopteryx. So I counted that as evidence for evolution. And Grayson also brought the prediction of transitional amphibian fish features, and we found Tiktaalik. So this is the total of all the evidence that has been successfully brought for evolution since I started doing this. A lot of other people have attempted to bring evidence, but if I looked at the evidence and there was something wrong with it, then I did not count it as evidence for evolution. So I'm inviting you to share your evidence for evolution. And I want to remind people, here's my evidence that I've brought against evolution. This is page 1. This is page 2. You can pause it and look at it if you want. And really, no one has challenged me on any of those things. I mean, successfully brought a challenge to my evidence against evolution. So I also would encourage people to challenge my evidence against evolution, because this theory is very problematic and more than problematic. Okay. It is nonsense. It's an example of how very smart people can come to believe something absolutely absurd. And that's the situation that we are in with evolution. But I want to know what makes evolution true. And I'm going to start by inviting Rod on. Thanks for being here, Rod.
Thank you very much for having me. It's great to see you again. So I'd like to see that list of the bits of evidence you had. You mentioned Gutsick Gibbon talked about transitions for humans. And I've actually been watching this series of videos where she's talking to a young Earth creationist, Will Duffy, and she's going through all of the evidence for evolution. And so far, I've watched 3 of them now. It's probably 9 hours worth of videos where she's covering all of this. So there's an immense amount. And I was just listening to her discuss the evidence for whale evolution, which I wasn't even aware of, that's been updated. And so very often when you hear people debating evolution, you'll hear little bits and pieces of evidence, a little bit here, a little bit there, a little bit there. And they pick those because they kind of stand out. They're a little bit more obvious, but there's a mountain of evidence. And I think I mentioned last time that I'm working my way through a vertebrate paleontology book. It's not my field, but every page, there's little bits of evidence that support evolution. And working in molecular biology, I never appreciated it. But in the evolution of vertebrates, from fish-like creatures to very exotic fish that don't exist today, to more familiar fish, to then land animals, tetrapods, and all of the diverse vertebrates on Earth now, starting from fish, there was a large number of bones in the skull. And you could have made a skull in many, many different ways, but it just happened to have this set of bones. And that set of bones has been passed on to all the descendants. And even, you could say that's common design or God reusing his plan. I think there's a problem with that, and we can get to it. But you run into a real problem when the functioning of the skull, the way the animal is feeding, the way the jaws are working, is completely different, and yet it's the same bones that are there but have been modified for this completely new function. That's a case where it would be reasonable to say that the designer would go back to the drawing board and design from scratch, not reuse the plans that he already had. For example, when human designers design submarines, they don't start with a 67 Chevy and say, okay, now we got the 67 Chevy. How can we make changes to this so it can go underwater? And in some cases, they keep things that they don't need. For example, they keep the tires on the wheels, but that they transform into something that you find underwater. That's not how designers work. Our repeated and uniform experience tells us that's not the way things work. And so
okay, can I stop you there before you
Sure.
go on? Because you've made quite a lot of points that I want to respond to. You said there's a mountain of evidence. You listed off your experience in hearing this evidence. And what I want to just like let people know, including you, is that if you pay attention to that evidence, you'll figure out that it is either, number one, it depends on the assumption of evolution. So it starts with the assumption of evolution, and then it presents evidence based on that assumption. So it's fine evidence if the paradigm is true, but if the paradigm is false, then it's not offering actual evidence for evolution. Second thing is that a lot of the evidence that is used for evolution is religious evidence, including some of the things that you just said are religious evidence for evolution. So, you can make religious arguments for evolution, but we're stepping into theology. We're not doing science, right? So if we're talking, I'm looking for scientific evidence for evolution. And most of it is either starts with the assumption of evolution. So it's not actually evidence that evolution is true, or it relies on a religious argument. So, and this is most of what is going on when people are saying there's a mountain of evidence.
All right, so I don't think it's true that when scientists start working on something, they have some assumptions going in. And of course, pretty much all scientists today assume that they're working within the model of evolution. But it doesn't have to be that way. You can accumulate a lot of evidence, and it's not a case where two people can look at a glass and say one says it's half full and the other says it's half empty, and so it's just your perspective. This is not the case where you can have a different perspective on the evidence. The evidence will clearly indicate one possibility and not the other. But if you don't like that, you can always say that if you want to assume that there's an intelligent designer or God, you are, and everyone is invited to, essentially, reinterpret the evidence in terms of creation. And it seems to me that's what creationists and intelligent designers generally don't do. They try to poke holes in the evidence for evolution, but they don't create a coherent explanation for the patterns we see. It's mostly poking holes. It's not, and actually, when they do explain it, it's usually it just doesn't work. For example, I think on one of your previous streams, you talked about the fossil record as being deposited during Noah's flood. Now, the thing is, and I remember seeing explanations like this before, that the slow animals got buried first, and the faster ones higher and higher and higher. The thing is that if you know anything about the fossil record, it doesn't look like that. You can see very clearly what the fossil record of a flood is, what that looks like. You can then see sand laid down. You can see fresh water, salt water, desert, all sorts of different environments. And that is not the pattern of animals that we see. We see fish recently in the most, there's fossils of fish that are 30,000 years old. And so it sounds like a good explanation to say it's from Noah's flood, but when you look in any detail at all, it doesn't look anything like a flood.
Right. But let me just start by admitting that I think the fossil record and what we see with geology, for me right now, it's the hardest thing to deal with for me in my view of creation and the flood. Okay.
What do you mean the hardest?
What I mean is things that challenges that people can bring to my view of creation, things that they can bring from geology and the fossil record. These are the hardest issues to deal with. Okay, so I'm giving it to you that the fossil record is difficult for my position, but this is one of the tricks that people do when they come on here, is that they, instead of giving evidence for evolution, they like to turn and challenge young earth creation. But it doesn't matter if my view of creation is false. It does not help evolution.
Oh
Evolution
yeah.
it has to be able to stand on its own, right? And the fossil record is not a friend to evolution. So there's many problems with the fossil record for evolution. So what are you bringing as evidence for evolution, or to answer the question, what makes evolution true?
Well, I'll give you one thing that I think is. I got to remember to talk about the fossil record. We're gonna. It's fun to jump all over the place, but I got to keep track. One of my favorite examples is the evidence that eukaryotes came about as a result of a fusion of two prokaryotic cells. It was an ancient archaeal cell that took in a alpha proteobacteria that eventually became the mitochondria, and essentially the two genomes fused and redundant genes were dropped randomly from either. And they have now found archaeal cells that are sort of intermediate with eukaryotes. These cells have a rudimentary cytoskeleton, and they have vesicle trafficking, which bacteria don't have. And that was a huge innovation that eukaryotic cells have. So these archaeal cells have that. And they even form these long extended structures that would allow them to bring in a cell, a, 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 a bacterial cell. And you can see how the membrane system, including the nucleus of a eukaryotic cell, formed from that. So there's a whole bunch of models for that, and a lot of them are testable, and there's evidence for them.
Okay.
And there's other evidence. Plus, we see that happening nowadays.
Okay. Hold on. We'll get to what we see nowadays, but we need to deal with this, because what you're doing is you're telling a story about the past. You're not actually giving me the evidence. You have not given me evidence yet. Okay. You've told me a story about the past, about a prokaryote and a prokaryote fusing together. You're telling me a story, right? And so what I need is actual evidence for the story.
All right, that's a good point, because this is a topic that I'm interested in. In general, it has nothing to do with this discussion at all, but it's like, how do we know what we know? And this is related to the fact that people are talking about AI now, and what does AI know? That AI can do amazing things, but it's not conscious. It doesn't have a mind. And so what does it really mean for us to know something? And so what constitutes evidence? And I would say these things are evidence. They are observations of things that imply something about the world. So the evidence is the genome of bacteria, or the comparison of that with the genome that you find inside mitochondria, the structure of mitochondria that resembles bacteria in many ways. The fact that the translation system of a mitochondria is more similar to the one in a bacteria than the one in the cytoplasm. The fact that we can see these processes happening now. There's other really interesting examples of that that I have to draw out. I don't know how I would draw it out, but yes, it's a story, but there's no mathematics when it comes to this. There's observations we make of the past. For example, fossils and
wait, don't go on to the next thing. Don't go on to the next thing. Let's talk about, you're bringing evidence, and now we need to talk about the evidence and whether it is actually evidence. Okay, so you brought the similarity between the basically mitochondria in eukaryotes, right, and a bacterial cell. right? Or
Right.
a prokaryote. Okay.
And the genomes of
Okay.
those
Yes.
two.
And the genomes. Yes. Okay. Now, so when you are, and so that I can take that as, yes, that, okay, that is evidence for your story, right? But when we're trying to reconstruct history, we need to compare ideas about the past.
Yeah.
So, what ideas have you compared to see if that theory about how, the eukaryotes and prokaryotes, or two prokaryotes fused, and how we got the mitochondrial, where do you get, like, what have you compared that to test against your idea?
Well, I mean, the easy one is that mitochondria are not descended from bacteria that live separately. That they arose a different way, and you know, you could just leave that as a mystery. You could say, well, we don't. I won't make any assumptions about how mitochondria got there, but I'll go on the idea that they're not descended from bacteria, and that's a harebrained idea. In fact, people didn't believe that. It was the first person to propose that was Lynn Margulis. She was I guess, the ex-wife of Carl Sagan, and so people were kind of nasty to her about it. They didn't believe it, and the evidence. Here's the thing: the evidence gradually accumulated so that everyone eventually accepted that mitochondria were the remnants of a symbiotic bacteria. And again, it's
So what would be the
observations.
scenario that would be ruled out? Like, what's the scenario that was ruled out?
Well, the scenario that ruled out is that you'd say it's the null hypothesis that mitochondria are not the descendants of alpha proteobacteria. That
Okay, and how do
they
you
didn't have
rule
a
that
separate
out?
origin.
How do you rule that out?
You have to weigh. Well, you look at the evidence for that and you say it's not compelling enough. And I guess the first bits of evidence for it weren't compelling enough to people. And they also, I guess, had a bias against it. It just didn't seem familiar or possible to them. And so it would have required stronger evidence to convince them, but eventually it did. Ideally, you're right. It would be better. You're taught in school that you have two competing hypotheses. So you have to have A versus B, but you can actually have A versus not A. You can just say someone's proposing A, and I just don't think it works. I don't have an alternate, but
Yeah.
I don't think it works.
And that's fine. And so how do you get the idea that it doesn't? How do you get the idea that not A doesn't work? Like, with this scenario, what is it? What are you relying on to figure out how the, eukaryogenesis, or the origin
I
of
guess
this?
I guess the way you would analyze it is say, okay, here's the evidence that someone, Lynn Margulis or the people who are her supporters, would say is evidence for bacteria. But if you can say there's another explanation for this, for example, there's another explanation of why mitochondria would have their own genome. There's another explanation for why that genome would be more similar to a bacterial genome than to a eukaryotic genome. There's another explanation for why the lipids, the cardiolipids on the inner membrane of the mitochondria, are things you only see in bacteria, but the outer membrane is not, because they felt that the bacteria was brought in a vesicle, and so the outer membrane was from the cell that took it in, and the inner membrane was from the bacterial membrane. And so there's that consistency. The fact that you see a simpler version of the electron transport chain in various types of bacteria. The fact that most of the genes that are necessary for mitochondria are in the nucleus, but a few of them are still in the mitochondria and get transported in by a mechanism that's completely different than all the other transport mechanisms. So you can, and the mechanism for transporting proteins from the cytoplasm into the mitochondria, the TIM-TAM complex, is very similar to a complex in bacteria that moves things into the bacteria cell. So what you can do is you can find alternate explanations for all of these. And at this point, there's a pretty long list of reasonable alternate explanations you'd have to have.
Okay, what is like one alternate explanation that was considered and discarded based on the evidence?
I don't know, but I don't know if there were. I think it was just the null hypothesis, the idea that it wasn't descended from it, but that was probably in the 60s or 70s. If you're
and I'm trying to get at what was the null hypothesis. What did they say? If it happened, this is what we should see. If it didn't happen, this is like what we should see.
In this case, yeah. In this case, it was just disputing that the evidence for it was compelling enough. There are cases where, yes, as you say, there are two alternate competing ideas, and there is evidence that should match one or the other. In this case, it was people proposing it and others just saying, no, it's too far-fetched, and that evidence isn't good enough. But I don't know how long the community was skeptical about it, but it's pretty much accepted now.
Right. Well, and so that's the problem, is that not only with what you're explaining, but with a lot of these evolutionary stories that are told, right? When you drill down and you try to figure out where was the comparison made, what was the null hypothesis, right? There isn't one. But I'm guessing in this case, okay, like many of the cases, it was comparing the similarities and then pitting that against random, right? And so this is the standard, but this isn't a proposal. It's not an actual competing hypothesis. It's not, so anyway, it's one of those kind of like, we tell the evolutionary story and then we look for evidence for the evolutionary story.
I don't think that's the case. I don't know how to describe it. But this is an interesting idea. I almost think you'd have to take one topic and go into tremendous detail on it, and then we could actually get to at the very foundation of what it means to say something is evidence and something indicates that one thing is true and not the other, or a bunch of facts support one story and not another story, and what would require. So yeah, I think you would have to really go into detail on that. But in this case, it's not always the case that you have to have hypothesis-driven research. There's plenty of people who do research by just going out and gathering things. They go out, they gather bacteria from unusual environments. Now, very often, once they learn about those things they've gathered, they come up with hypotheses and ideas that they can then go test. But it's not always the case that there's an alternate hypothesis or a competing theory. There's just that it's not true. It's what you're saying is not true, and the evidence doesn't support it.
Okay. Now, when we are testing something that we can actually do in the lab or see the process happening right now, then we don't need a competing hypothesis, right? Because we can actually like test the idea and see that it's happening, right? But when we're talking about historical events, right, then we do need to have competing hypotheses. Otherwise, we're just telling stories about history and we're finding bits of data to try to support our story, right? If you can't say, well, we compared it to this idea about history, then you're not actually doing science. You're just doing storytelling.
Well, I mean, I think you're right, but it's actually the opposite. I mean, in a lab, when you're doing experiments on on things that exist in a lab, the functions of a cell, you do have alternate hypotheses, because you're never looking at anything directly when you do science, at least in most science. You're looking at a gel, which is uh, looking at DNA strands, which you assume are moving on this gel in a certain way because of a certain property, which you assume. So there's so many chains of cause and effect between something going on in a cell and what you actually have to see. You have to have a lot of control experiments to make sure everything is done right, and you very often have to have competing hypotheses because you're testing some model of a mechanism or some function that's going on in a cell. When you're looking at things that occurred 100 million years ago, I think, well, I mean, they do test hypotheses in a way when it comes to the fossil record. For example, the best example is that from the creatures that were transitioning to life on land, the fish that actually had stubby fins with fingers on them, but they know couldn't move on land, to the animals that could move on land. Um, they knew when that was occurring, and a guy, I forgot, Shubin, looked at a geological map of the world and said, where are the rocks from the exact time we would predict that this intermediate will be found? He isolated from something, I think, in Greenland or northern Canada. They looked at the rocks and they found the exact creature they were looking for, a fishapod.
Yeah, Tiktaalik. Yes.
So that
if
was,
you notice, yeah. Tiktaalik was one of the things that I gave credit as evidence for evolution, because they predicted that they would find this type of creature. They went out and they found the type of creature. So I gave that as evidence for evolution. That's positive evidence for evolution. So, and that's the kind of thing, yeah, that's when you can do that, then that's good evidence. But when you're just looking back in and making up a story about the past, even if you can find reasons for your story, right? If you're not comparing it to anything, then you really can't say that your story is true above another scenario. And in the case, so many times with evolution, they either won't admit that they are comparing it to something, even though they're comparing it to God created, or they say there's no alternative, evolution is true. Like, so they don't compare it at all. So they just assume evolution is true.
I think no scientist compares it to the possibility that God created it. That's true. But they do compare it to other possibilities. I mean, I don't know in detail how paleontologists do their work, but I know that they find skeletons, they dissect them finely, they look at the anatomy, they compare it to the creatures that lived just before or at the same time. They make hypotheses. They can make hypotheses on the functions related to the changes in some anatomy. So, for example, if they see a change in the way the jaw is hinged, then they would make a hypothesis that this animal changed its feeding mode. And they'd say, well, if that's true, then the teeth should be different this way, or we'd expect this to be true in other parts of the skeleton. So in reading my vertebrate paleontology book, I have come across a few cases like that. I'm starting to think I need to reread the entire book and take notes on every page for every little scrap I can see of something that would count as evolution or evidence for evolution, because, you know, as I said, there's these standout examples of evolution: peppered moths and the horse series and this and that.
Okay, wait, you're introducing too many topics.
But no, I'm not introducing them.
Hold on.
No, I'm not. I'm just giving examples. I'm just saying.
I know, but
there's
I
a
want to
few
finish.
Examples that. Okay, yeah.
You've said too many things, and I need to respond. Okay, you can give me your examples in a little bit, but I need to respond to something you said. You said scientists would never compare it to God created. But earlier in this conversation, you did that very thing. You
Yes.
said, we see this thing, and a designer would not have done that. And so you are comparing it to God created. So you're a
Yes.
scientist, right?
No.
Well, yes, you are. You are a
No.
biologist. Yes, you are.
Well, I
You
have a
may not
background
be
in
actively doing research, but you are a scientist.
I have a background in biology, and as I said it, I guess, in the chat when you were talking with Cornelius, that yes, Darwin might have specifically compared his ideas to a creator then, because a creator God was the scientific explanation at the time. So he was trying to show why his model and his evidence better fit the data, better fit the evidence that was out there. Now, when scientists are doing science out, they don't. There's only a handful of papers that I know in the last 20 years where they actually said, where they actually addressed. Usually, it's intelligent design claims, but for the most part, it's only when people are debating evolution or talking philosophically about evolution that they'll say that this is not the way God would do it. And you're saying that's religion. I don't know if I call it religion. You could say it's a theological argument, but it's perfectly reasonable to make a theological argument when you're debating the possibility of design by a God. That's what a theological argument is, and you're not talking about whether God loves us or whether Jesus Christ was his son. You're talking about God the designer, and God the designer is something we can relate to because we are designers. And so you can make arguments about what a reasonable designer would do versus evidence that shows the conspicuous lack of a designer, which is what I would say the evidence shows.
Right. And that argument is one of the strong arguments for evolution. And actually all of the strong arguments for evolution are all theological. They're all religious.
No.
Okay.
No,
and
I don't think so.
You're saying no, but it will take too long tonight to go through all of them. So I don't think we can. We might just have to pick it one at a time, but we can start with the one that, you just said, that God wouldn't design it this way, right? Before we get too far off track, though, oh, you're frozen. I can't see you. Okay, you're back. But you said something toward the beginning that I wanted to give you a chance to tell me your evidence. You said, like, related to, this eukaryogenesis, we can see this happening now, right? I don't know. You didn't use the word eukaryogenesis. The prokaryote engulfing another prokaryote. Okay. You said we can see this happening now.
Well, right. There's an amoeba, I think it's Pollinella, that has I think it's a cyanobacteria living inside it that is symbiotic. It's like the ancestor of a chloroplast, but you can infer by doing DNA sequencing that and comparing the genome that it happened just a few million years ago. And the thing is, you can separate them. Actually, you can take the cyanobacteria out, and it will survive on its own, and the amoeba will survive without the cyanobacteria, but they don't survive quite as well as they do together. So it's almost like the process of endosymbiosis occurring over again. There's some other examples that are really cool, and I didn't hear about these through most of my career. It wasn't until I interviewed for a job. So the ancestral eukaryote took in a cyanobacteria after it got mitochondria, and that became the chloroplast. Then another eukaryote later on ate this, and that entire cell became a new chloroplast, but it has an extra nucleus. It has a nucleus. So in other words, there was a cell with a chloroplast and a nucleus that gets eaten and becomes symbiotic with the larger cell. The larger cell has its own nucleus, but then there's two membranes, and between that, there's the remnant of the nucleus of the original cell, which is called the nucleomorph. And then inside that, there's the chloroplast. And I think there's even another case where something even ate that. So you have a nucleus, a nucleomorph, a nuclear morph sandwiched between two membranes, and then two more membranes with another nucleomorph, and then a chloroplast in there. And all of these are making genes that need to go back and forth. And so again, that is an example of what's called tertiary endosymbiosis. So one cell eats another and they become symbiotic. Then something eats that and the whole thing becomes symbiotic, and then something eats that. It's just mind-blowing. And again, it's natural processes that produce this complexity. You even if there was a designer, you'd have to say, where was the designer when all this was going on? Did the designer have their back turned and all this occurred? So,
I love it. Okay, Rod, I love it because you don't hide your religious arguments. Okay, so many times people are hiding their religious arguments, but you're just blatant making.
Well, if they're hiding them, they don't realize they are religious arguments.
I know well, that's what I mean. I don't mean they're intentionally hiding them. I mean, they could be, but more likely they don't even realize it's a religious argument. But you are making a religious argument and you're saying, yeah, it's religious, deal with it. So good, let's deal with it. Just a quick point on the symbiosis. I'm not arguing with symbiosis, right? The only thing I'm arguing with is the storytelling about the development of the eukaryotic cell and the mitochondria from, a billion years ago. I'm saying you can't look at symbiosis today, right? Just two things that are, we're living together in a mutually beneficial relationship and extrapolate to a billion years ago to get the origin of mitochondria. There's a lot of issues, right? Like, it's the mitochondria sitting in there there's a lot of difficulties, and I'm not prepared to give them today. I have read about them in the past, but there would be a lot of transformation that would be needed for if that was what actually happened, right?
The only person I know who's addressed that is Jonathan McLatchie. I think he was wrong in what he said, but yes, there are issues. For example, it's difficult. One thing that's obvious is that mitochondrial ancestor lost a lot of genes that it didn't need anymore. Because the genome has only, I think, 13 proteins now. And many of the genes got transferred to the nucleus. And that's a difficult process. What it implies is a mitochondria in one ancestor, lice opened up and the DNA escaped into the cytoplasm. And just by luck, some of it got into the nucleus and wound up being expressed. And so gradually the genes got transferred to the nucleus. So you could say, okay, if that's true, if that process is true, which I admit always sounded to me like, wow, how does that happen? I'll admit, from the time I started in my major of biochemistry, I'd see things and I'd think, wow, how did that evolve? But in this case, yeah, how did all of these genes over the course of 2 billion years get transferred through the nucleus? Is there evidence that we can find that process is occurring? And so, yeah, that's the kind of thing that would be evidence that supports it. I noticed you're very good at keeping the topic focused, because I kind of want to jump around a bit. I did want to go back to that design argument. Cornelius had a slide from a textbook by Futuma where he said that Futuma said a designer wouldn't do it this way. And Cornelius said, that's obviously a theological argument. It wasn't, because they didn't say God did it. They said a designer did it. And if you remember the early days of intelligent design, they were perfectly willing to say we weren't designed by God, we were designed by intelligent aliens. They said it could be God, we think it is God, but it could be super intelligent aliens that design it. Obviously, if it's super intelligent aliens, it's not theology. If it's God, it is. But in both cases, it's reasonable to talk about what a designer would and wouldn't do, because designers, no matter how impressive they are, do things for a purpose. And there's things aspects of the world we can see that say, if there was a designer here, it's reasonable to think they wouldn't have done that. And if you can't say that, If your designer works in mysterious ways and can do absolutely anything for any reason, then there's no way to tell that it was designed. There's no evidence you could ever come up with that would disprove a designer.
Okay, now you're actually making a great point about aliens, right? That if it's about aliens designing us, then it's not a theological argument. Okay, great. Point taken. Okay, so now, but let's just so if we're talking about aliens or God, how would you know what a reasonable designer would do? Like, if you don't know anything about the aliens, how do you know that their thought process would be anything like yours or God's, for example? So, what are you using to figure out what a reasonable designer would do?
Okay, well, let's say one example is that if there's a designer, God or aliens, they're creating living things because they want these new species to be on Earth, and they have a place, they have a reason for being here. What no creationists have ever talked about, as far as I know, or intelligent design advocate, is why species disappear. Why do species go extinct? Because you can't just explain how new species come about via the designer. You have to also explain why they disappear. Because if, for example, if the designer wants to produce some new creature, but there's creatures on Earth that are going to eat it immediately, they need to get rid of those before they can come about. And we're all familiar with the idea that the only reason we're here is because the dinosaurs aren't. And so God must be causing creatures to become extinct at the same time that they're being created. Now, we can see a lot of reasons why they become extinct, but one good reason is a giant asteroid hits the Earth. That asteroid that hit 67 million years ago, and I found an incredible fact about this. They know that the asteroid hit in late May to June. So let that sink in for a second. They know what time of year it hit, but we can go to that in a second. But anyway, so if the designer has created these animals that we all realize would be the most magnificent things you could ever see on Earth, and he decided he had to get rid of them, why let a big rock hit the Earth? Because obviously he's not going to be able to control what things become extinct and what don't. It would be better to kill them individually, or maybe the rock just hit when his back was turned and he didn't want the asteroid to hit. So in other words, creating all these creatures and then letting them be wiped out by something like that, or for that matter, the Permian mass extinction, which was even worse, that is inconsistent with a designer who is planning something for life on Earth. The patterns we see of creatures coming into existence and then going extinct matches what we can infer natural causes for that. We can infer that the climate was changing and permitted this. We can see that animal life first arose when the Earth was a snowball essentially for 160 million years, and it was only when that ice melted that animals started to become complex. Was God just sitting around waiting for the ice to disappear? It seems there's a conspicuous absence of a powerful intelligence watching over us. Whether you think it's aliens or whether you think it's the God of the Old Testament, it just doesn't seem to be there.
Okay. And thank you for recognizing that that is a religious argument, right? So that we're not making a scientific argument for evolution here, right?
You actually can. Well, no, you can. It is a scientific argument because you can make scientific arguments about the actions of a designer. Designers work in the natural world. Designers do things. And
what type of designer, though? Like, if we're talking about aliens, what is your case for how those aliens think? If your designer is God, what is your case for what is your scientific case for how God thinks?
Well, the interesting thing about working on a designer hypothesis is that you learn about the designer sometimes from the design. There's a lot of people on my side of the debate that argue with intelligent designers and say, no, you can't invoke a designer until you tell us all about the designer, or until you prove the designer exists. That's not true. Sometimes you learn the designer exists from the design. In other words, you see the designed object and now you infer it. But you can only do that up to a certain point. For example, I'll give you 3 examples. Archaeologists discover stone tools on an island in the Pacific, but these are dated from 3,000 years before people ever made it to that island. Well, now you have to change the date. We know who the designers were. It was people. We know that people can go from one island to another by boat. In this case, we just didn't know the timing of it, but the designed object is now evidence that there were designers there, and this was not a natural process. Recently, and I know Stephen Meyer of the Discovery Institute, here's my second example. He jokingly mentioned something that astronomers had been talking about. There was a star that was showing really unusual activity that no one could explain. And one astronomer jokingly said, well, if there's aliens there that are super intelligent and built a big structure around the star, that would explain it. And they were only half serious, but most people would reject that. Yes, that would explain it. But first, you haven't established the existence of intelligent aliens there, which you kind of need to do. Second, we know that intelligent life is going to be exceedingly rare in the universe. We might be the only intelligent life in the entire galaxy. So you can't just say, oh, it's aliens. In fact, even if we got radio signals from there and we knew there were aliens there, that wouldn't be proof that they had built something. It could be something just was going wrong with their star, but it would make it more possible that it was some alien technology. So in that case, it's not reasonable to assume aliens to explain the thing we don't see. In the last case, intelligent design on Earth, we have not established the existence of God. I know religious people have a separate faith that God exists and a certainty that God exists, but no matter how certain you are, you cannot start with the God of the Bible as an explanation. Science got started when scientists rejected authority from the ancient Greeks and from the ancient Romans. I remember.
Wait, you're introducing another topic. Hold on. Let me at least respond to that. Because now I'm having trouble even keeping track because we're all over the place. So
I know, sorry. Here's the thing. I love this topic. And for my whole life, I've been listening to your streams and others as I'm hiking my mountain, and I'm so eager to talk and jump in, and I've never been able to, and now this is the first time I can. So yeah, sorry.
Yeah, no, okay. Now let me try to get back to what I was thinking about, which it sounded to me in there somewhere you were actually making an argument for intelligent design. It sounded like you said we can look at things and see that there was a designer.
Yeah.
Okay, yeah. So would you say we can look at life and see that there's a designer?
I would say that the question of whether life is intelligently designed is a scientific question. It's a question that can be investigated. Yeah.
Awesome. Yeah. Okay. I like that because a lot of people don't think so, but I think that's true. And I do think, of course, there is evidence, strong evidence for the existence of God, but that's kind of like a totally that would be going too far afield. So, okay. How would you say that we can test whether there is a designer scientifically?
Well, okay. So let me think. As an example of people who use a design hypothesis and the way you correctly use a design hypothesis, consider Easter Island, with those giant heads. I saw a great documentary where there were people studying the heads with a design hypothesis. For example, they were saying, okay, who built them? Well, they figured out that it was the people who were still on the island. It was their ancestors. They said, why did they build them? Well, they inferred from the history of vegetation that the island was dying, the plants were all dying, and that they were desperate for help. So they made these heads to appeal to the gods. And then the question was, how did they do it? Because these things are huge and they just didn't have the technology. And that's where someone on the Joe Rogan podcast would say, well, aliens must have helped them with these giant heads. But no, it turns out this one physicist looked at the heads and he looked at the bottom. He listened to the fables and the stories that the people on the island told. They said that the heads danced. They danced to their location, and that made him think of something. That objects, if you rock them, some will move forward, but they have to have a certain shape. So they went over to the heads and they looked at the shape, and lo and behold, they had the right shape for that. Then he looked at a topographical map of the island, because the physical equations show you that if you try to go up too much of an incline, the heads can't do it. And they found that from the place where the heads were quarried, there were no place on the island where there was a hill that they couldn't pass. They only found them where the gradient wasn't too strong. And finally, they did the last test where they did an experiment. They made a head, and they got a whole bunch of volunteers with ropes, and they found that if they pulled on it like this, it would actually move forward slowly. So they, in other words, they did experiments from all the sources, including the stories of the island, to put together an understanding of how these were intelligently designed. Contrast that with what they didn't do. They didn't sail up to the island, see these heads, and say, natural forces could never make those heads. They must have been intelligently designed, and then left. That's saying something is intelligently designed is just the first step. You have to say, okay, here's a case where you do have competing hypotheses. You say, what would we expect if this is designed by a designer? And we don't have to make too many assumptions about the designer. The designer could be Polynesians, or it could be God, or it could be aliens. We don't have to make too many assumptions. But what are the minimal assumptions we could make if it's designed, and what are the assumptions we make if it's the result of natural processes? There's thousands and thousands of differences. Even if you say, for example, living things will be complex if they evolved, they'll be complex if they were designed. So that's not something that will distinguish. Complexity is not a measure, but there's got to be some ways.
Would you say that if I took just a random assortment of zeros and ones, and I just, like millions of them, and I just shuffled them around and put them into like I shuffled them up and then put them into different computers, do you think I could get a computer to run with that digital code that was a random assortment?
Never.
Okay, never. Like never.
Never. Like 0.0000, ones out to the end of the room. No, you wouldn't.
Right.
And that's true also of programs. If you make random, I have to admit, I don't know any computer programming, but if you make random changes to a program, you don't get a new program, you get junk immediately. Like one comma will destroy it. Now, there are people who created a program just for fun. This program has only 4 symbols, and the way it works, and I couldn't describe how it works, but the way it works is you can make changes in it, which will change the program. In other words, whether something is evolvable or not depends on kind of how it's put together. So some programs you cannot evolve. You cannot make any change at all. And others you can, and it will change it. So,
right. But a code that will run a computer is never going to pop out.
If you're saying, can you get complexity in one step? No, there's a barrier. And it's a statistical thing. You could say, well, yes, you'll get it 1 in a million. But if it's more complex, then you'll get it 1 in a billion, then 1 in a trillion. It depends on how complex it is. But no, you won't get it in one step.
Okay. So then I want to bring that and apply that, because the DNA code is a code like a computer code, but even like more sophisticated than any computer code intelligent beings have built. Right?
Yeah. Well, it's not like the codes we make where if you leave out a comma, it's junk. With DNA, you can make lots and lots of changes, and you still get something that works. Most of the
Right.
time.
Well, I'm
yeah.
not talking about like the changes you can make to it right now. I'm talking about where it comes from, because we're trying to establish, does life have a designer? And I'm saying everything in life, right, that we know of has a DNA code that's more sophisticated than any computer code. So
Yeah.
when we're talking about where did that code originate from, you said for a computer, I am never going to get it by a random shuffling and trying to stick that in a computer and make it work. But what would you say about the DNA code? How did that originate? Could that have originated? And if so, what's the difference?
Well, you've picked the right topic to debate, because that's the thing that we know less about than anything else. We have fossils of animals that go back, but we have no fossils of DNA, although we can infer some things from the way living things are put together today and from experiments which we can do in the lab. And one of those is that DNA was preceded by something. It was preceded by RNA. There's good evidence that the first genetic molecule was RNA, and that RNA did two roles. It stored genetic information. It might have even existed before genetic information actually existed, but it also worked as an enzyme. And now enzymes
now
are
you're
mostly
storytelling,
proteins.
Rod.
No, because RNA is enzymes now. The most important jobs in the cell are done by RNA enzymes. And
right.
And so,
but this is what I'm talking about, with starting with the assumption that evolution is true and then using what we see as evidence for it. Okay. So the only reason you're saying there's evidence that RNA was before DNA is because you're trying to figure out a way to make this naturalistic process work. And yes, if that's our only option, if our only option is that it had to happen by physical chemical processes, maybe RNA is the best explanation, but the problem is it's a terrible explanation and it's failed with every test that we've tried to do of this.
Well, no, I don't think that's true, but I do think you're right that it is based on the assumption that life came about by natural processes. So I think that is true, that when people started to think about this, evolution and the evolution of life by natural processes was already pretty much established and accepted by the scientific community. And so, yes, they were looking for natural explanations for how life got started. And as I'm sure you know, that a lot of people working on this or who were associated with it jokingly said, oh, we give up, it's aliens, and yeah, maybe they didn't want to say God did it, but some of them were willing to say maybe, panspermia. You've heard of that. That's where life started on some other planet and spores traveled here, like one of my favorite movies, Invasion of the Body Snatchers, and then life started here based on that. Of course, that gets rid of the problem of how life started on that other planet, but they're just putting that explanation off. So yes, it was a very, very difficult problem, and they are looking for a natural explanation. And I would say that even though, despite what you hear from enthusiastic defenders of this, it's one of the topics that we know the least about. So we don't know nothing. James Tour, I'm sure you're familiar with him, says we don't know anything about the origin of life. We know a tiny bit about the origin of life. He's not really accurate with that. There is, I think there's good reasons to believe that RNA was one of the first molecules. It can be produced much easier than DNA. There's other intriguing bits of evidence that suggest that maybe metabolism even came before RNA. If you ever read Nick Lane, he has a book out that explains it. It would have been those deep sea alkaline vents where there's chemistry there that that eerily resembles the chemistry inside a mitochondria that produces energy. And so, I admit there's little bits and pieces of evidence, but I would say that you have to put the origin of life in context. The formation of the solar system, obviously natural processes, and the subsequent evolution of life, also natural processes with a conspicuous absence of an intervening intelligence who might have blocked the asteroid. So in other words, if there was a designer, they were present for a really small period of time and then they vanished. And that doesn't seem like a reasonable designer.
Because a designer wouldn't have an asteroid hit the Earth?
Yeah, I'd say if they made stegosaurs and tyrannosaurs, and they wouldn't want those all to be wiped out. And if they did want them to be wiped out, an asteroid is not the best way because it's kind of unselective. They might have wanted to pick and choose which ones to die out. As it is, it was the birds were the only dinosaurs that survived, the only dinosaur descendants. And actually, about the claim that this is a religious argument, I'd say it's not, and yes, it is in a way. It depends on the context of the discussion. You can talk about a designer, whether it's God or anyone, from a non-religious perspective, but consider another thing. We know where earthquakes come from, right? I don't think you have too many of them in Utah, but we know that the crusts of the earth sit on these giant plates and they're sliding past each other. And when they stick and then jump, that's where earthquakes come from. And we know a huge amount about how earthquakes come. They can measure the movement of these plates and they can predict when the San Andreas Fault is going to go. Would you say that's just a religious explanation?
No.
Right. Except in Hinduism, they explain earthquakes as the earth sitting on the backs of a bunch of giant elephants. And when one of these giant elephants moves a little bit, shifts its balance, that's where earthquakes come from. So to a devout Hindu, saying that's where earthquakes come from, to them is a religious argument. But of course, seismologists don't think it's religious. They just think they're figuring out where earthquakes come from. And it's the same way scientists work today. They are looking at how life on Earth came about and how it evolved, and they do not feel they are making religious arguments, even though there are lots of religious people who take exception to that. You can't help but to impinge
what alternatives have they identified? What possible alternatives?
For which?
So, like, they're looking to find how life could evolve by chemical and physical processes. Okay. Is there any other alternative that they are considering, or is there a way that they could rule that out? Like, is there a test they could do to just rule it out?
Well, I'd say the alternatives are obvious. One of them is that it's designed that creatures, either God, an overseeing intelligence for the whole universe, or super intelligent aliens, like in 2001: A Space Odyssey, those intelligences crafted the first self-replicating cells and just let them take off and evolve. That's one possibility.
Are you saying scientists are considering that? I'm not talking about intelligent design advocates. I'm saying
I don't think they are. No.
Science. Okay.
There's another
so they're
one.
not actually they don't actually have any alternatives that they're considering, right?
Well, there's panspermia, which is that spores from another living world came here and seeded life. And again, that puts the question off, but you could always say, well, if you were on that planet, it would be kind of obvious how life started, because the life there was a little different and the conditions were different. And so, yeah, life could start there, but then it got here and life, that's not a great explanation. And people view that as just putting off the question.
Okay, so, yes. I didn't mean to actually take us too far off, like on origin of life. Because we're talking about what makes evolution true. And a lot of people want to separate origin of life from evolution, even though I think if you're trying to propose chemical and physical processes bringing about, life on Earth, you should have them connected, because you're going to have to get both processes to happen, right? But because they're too scared, because they know abiogenesis has no answers, they want us to give them the first cell. So I grant them the first cell. Now, how do we evolve, right? What is the evidence that we have evolved?
Well, no, but origin of life and evolution are two completely different topics. Origin of life requires a monumental it requires molecules coming together by luck to produce a self-replicating set of molecules, and that's a very, very difficult question, and we certainly don't see that happening today. Once you get the first replicating set of molecules, which is essentially a living thing, then evolution can take over. And what evolution is that when you have an entity that contains the information to code for itself and to reproduce, and it does reproduce, there are going to be random mistakes to that information. And those random mistakes will lead to changes in those entities and a gradual ratcheting up of complexity.
Okay, so let's say we have the DNA code for the first cell in life, and we need to get random changes, right, to be able to make it to progress as a code to be able to bring about the diversity of life. Now, let's just take the analogy, and if you have an objection to the analogy, let me know your objection. But let's just say that I have a computer with a code, and it works great. Now, if I start introducing random mutations, am I going to be able to produce a bigger, finer, more complex computer?
Well, there's a huge problem with your analogy there. And I noticed you made this when you were talking with Cornelius. And that is, and everybody makes this mistake, including the people who accept evolution. It's okay. First of all, remember the analogy I gave you that some programs just cannot be changed at all, and others are more amenable to change. So let's assume we have a program that is amenable to change. In other words, changing one little comma won't junk it automatically. So it is amenable to change, but that doesn't guarantee that the changes are going to be helpful. Okay. So you make a change to your computer. Most of the time, it won't do anything. It won't have any effect. Some of the time, it will make it worse. Very rarely will it make it better. But the problem is you're considering one computer. Now say there's 10 million computers, and we're going to make random changes to all of them. For many of them, it's not going to matter. For some of them, it's going to be worse. And for a few, it'll be even better. Now take the ones that are worse, get rid of them. Take the ones where it's better and make a lot more of them. And take the ones where it doesn't change, make some more of them. And then do that again, make changes to them. Random changes. Some of them are going to work worse, get rid of them. Some of them won't be changed much, keep them, make a few more. Some of them are going to be a little bit better. Maybe 20 out of 10 million. Make 10,000 of those copies, and then just keep doing that over and over. And that's the iterative process. That's how you build up complexity. You never get it in one step. All of the most sophisticated creationist and intelligent design arguments against how you get complexity from this random process. It's only random in one step. The selection isn't random. But all of these assume you're only doing it to one individual. And that's in superhero comic movies, you make mutations and you get superpowers. In real life, you get cancer. Most mutations are harmful. But that's, it's populations that evolve. It's not individuals that evolve.
Right. And, I think, though, that you're overestimating the ability of random mutations and natural selection to eventually be able to produce greater and diverse codes.
And that's the entire argument. That's where the whole thing hinges on.
Yes.
And so what you have to do is you have to look at proteins and say, well, how easy it is to change them, how easy it is to get new functions, how easy is it to change the processes of a developing organism. That's where it comes from. Because we know that, I guess you could, in a way accept that if you make random changes to a lifelike entity, whether you evolve into something more complex or whether they all just die depends on how easy it is to get new functions in that particular setup. And so I would say the evidence is that it does work in living things, because when you look at the structure of living things, the patterns of DNA, the patterns of genes, the patterns of proteins, you see an iterative process which is increasing the complexity of different lineages.
Well, actually, no, because this is, again, the type of evidence that starts with the assumption of common ancestry. So it starts with evolution is true. Now let's compare these animals that had a common ancestor, and let's see all the changes that we say happened, right? And of course, for an evolutionist, every, new thing that's introduced is a mutation, right? And so you assume from that you're getting all these great new features with mutations. But, there is another option. No, they didn't develop through mutations. They were created. So if they were created, you have to assume evolution is true to get that evidence, right? To make that evidence.
I don't think that's the case. No, you gather the evidence, and yes, people assume that evolution is the case when they're gathering evidence. But the nature of science is that anyone is invited to provide an alternate explanation. Your alternate explanation has to fit the evidence better. So you have to consider all the evidence. You can't throw out the evidence you don't like. You consider all the evidence and you say, here is why a designer is a better explanation for this. And if living things were designed, that would be easy to do. But no one has done it because it's not easy to do, because living things evolved. It's like this. You look at Mount Rushmore. Intelligent design advocates love to talk about Mount Rushmore. They say, looking at Mount Rushmore, it wasn't carved by wind and erosion, obviously. And I'd say, yeah, that's true. It was designed. You can study Mount Rushmore from the point of view that it wasn't sculpted, it was eroded. And you could talk about clouds looking like faces. You can talk about the mountain near me, sleeping giant, which looks kind of like a person's profile. You can talk about the face on Mars. You're mainly going to be spinning your wheels claiming that Mount Rushmore was not carved. On the other hand, if you claim that it was carved, you can show the name of the guy who did it. You can show the history. You can show the photographs. You can go to Mount Rushmore and see the drill holes and the dynamite holes and see the rubble below. In other words, if you pick the right way to understand things, designed versus natural, you're gonna go really far. If you pick the wrong way, you're going to spin your wheels. And the people who've been spinning their wheels are intelligent design advocates. All they can do is make general claims about, common design, whatever. And it's the biologists who've been phenomenally productive for the last 200 years. I can see you disagree.
I mean, strongly. I mean, we've been playing around for, however long, with genetics and trying to make evolution work. And it doesn't fit. It doesn't fit our observations. I just listened to a bunch of scientific presentations, the latest and greatest in genetics. And I was amazed at how many presentations talked about the problem with mutations, how difficult it is in their observations when they're actually doing experiments with fruit flies and, various nematodes and things like this, to actually get something.
Oh, okay. I'm interested. What can you tell me? What were these presentations? Just out of curiosity.
Yeah, they were at a genetics conference. Yeah.
Which kind of genetics?
Okay, all right. I see. I'm gonna have to blow my cover. Okay, I was the creationist at an evolution conference. It was the.
That's great. No one mind. Yeah. No one would mind. I mean, they would disagree with you.
No, they might not let me come back.
No. They would. You know that a famous creationist presented at a genetic conference. This was during COVID, so it was
Yeah, I know
Sal
Sal. Yeah,
Cordova,
Sal's been on my
and then
channel talking about that.
I think I
Yeah,
forgot whether it was Jonathan Wells or Paul Nelson presented at a developmental biology meeting. They had a poster, and
great.
people spoke with them. They said they disagree, they think they're wrong, but they were polite, and they engaged with them. So yeah, no,
Right.
don't worry. No
Yeah,
one's
and
going to
so,
object.
but what I heard was, over and over again, presentations where things weren't fitting the paradigm, where, we were finding many instances of convergent evolution, of course, assuming the evolutionary paradigm, where mutations are causing problems and not trending in the way that we need them to, selection not trending in the way that we need it to, and even difficulties with, hey, how meiosis, how do we evolve meiosis when meiosis it introduces double strand breaks, and it's not fully repaired properly, and it's causing mutations, and mutations are supposed to be why would we want to be stopping mutations? These are supposed to be the variation drivers. So there's sort of I think, a disconnect where they're recognizing the problems with mutations, and mutations are not building the great diversity that they're supposed to be building. And yet there's such a commitment to evolution that nobody can consider an alternative.
Well, I mean, it sounds like in these meetings, yes, they had a hypothesis that was being, or an assumption that they were finding the evidence was running against, but they weren't testing evolution versus creation. They were testing one particular idea in the context of evolution that could very well have been incorrect. In terms of mutations, I'm not sure what, without mutations, the evolution wouldn't occur at all. Or without, there's other types of changes besides point mutations, of course, but there's a balance between so much mutation that you die out, and enough mutation that you can adapt to new environments and proliferate. So yeah, I have to see what the context of those discussions was.
Yeah, well, but that's the thing, is that, what I'm trying to do here is have people bring specifics. That way we can evaluate it, right? Because you're giving a nebulous thing, right? You're saying, oh, we have all this information, we have all this evidence here, but there's nothing concrete that you're offering. And
all right,
that's
you're
what
right.
I'm doing
Yeah.
to you right now too. But this is supposed to be, I often bring my evidence against evolution, right? And it's mostly never challenged. Like, so many things that I brought against evolution, nobody challenges it. And I think it's because they can't. Okay. But then, now, like, I'm wanting some specifics for evolution. And so, that's what I'm asking people to bring, because
All right. No, that's true.
Yeah.
We could pick a topic and go into a lot of detail. In fact, I was hoping to start my own YouTube channel, and I picked a scientific paper that I talk about first. It's how primates lost their tail. I found this paper a while ago, and then I saw a gut-sick gibbon. Erica actually mentioned it. I don't think she went into detail, but I wanted to do what we used to do in graduate school, which was you present a paper in front of a whole room, and you go through every figure and talk about every experiment and how they justify the explanation. And this is a really interesting paper that suggests that this big change, primates losing their tails, was random mutations that were not guided. And so, but that's an assumption, of course. And it would be interesting to talk about it with you, because if you presented it in graduate school, no one would think of presenting the alternate idea that was guided. So you could actually have a very fresh perspective on a lot of this. But that would be an example of talking about a single topic, like the genetic code, or a single paper even. So, yeah.
Right. And I think that's great. But I also have to say up front that, I'm not going to be able to offer a comprehensive explanation for why God, created such and such and did these things. I'm not going to be able to do that because I believe a story. I believe an origin story, right? And I don't have access to information about why God did certain things. Okay. And I never will have access to that.
But see,
Right.
that's the thing.
So,
You don't need to have access another way. For example, in that Easter Island example, they didn't they couldn't ask the people who lived 1,000 years ago, why did you make those heads? They inferred it from evidence they gathered, the history of pollen on the island and the bones and the examples of warfare and cannibalism. So that was their inference. And you could do the same thing.
yes,
You don't
there are
have to know
some
anything
things.
about God. So you could say you don't know anything about God, but then you study the natural world and you find out things about him. In fact, that's what people used to believe for most of history. That's why it was called natural theology. So you can infer things from God based on what you see in the natural world and then make hypotheses. Well, if that's true about God, then we should find this. For example, you probably know the quip that someone said, well, what can you tell about God from looking at the natural world? He says he has an inordinate fondness for beetles because there's more species of beetles than just about every other type of animal on Earth put together,
Okay,
So,
yeah, and that's a great point. And so I'm not saying there's nothing I can know about God, right? There's a lot of things that I do know about God. So, there's a lot of things that we can, discuss about that, but I'm saying there are limitations, right? And my whole point about this is that, so it's often that people are saying, well, you believe a religious story about origins, which is true, right? I believe in a supernatural an event. It's a religious idea that I have. Now, but evolution is being presented as a scientific theory, right? So it has a different standard, right? Because it if it's not a religious theory, if it's a scientific theory, we should be able to present scientific evidence for it. So that's why I'm holding a different standard for evolution than I am for my story, because my story, I admit it's religious, right?
well, the details of God might be something you can't know, but to the extent God makes living things on Earth for a purpose and does things in our world, we can study that and make inferences. And yes, we'll always be limited. You can study some science is, like I've always thought paleontologists must be really sad people because they study these creatures that lived long ago and these things were so amazing and they'll never ever see what they actually looked like. Isn't that disappointing? And so, but they can still learn some things. And it's the
Yes.
same in this case. You may never know everything there is to be about God, but you can infer a few things. And as
Yeah.
for science, I think science as a more general explanation, science is trying to understand anything that happens in the natural world. There's nothing really fancy or special about science. It's using common sense to answer difficult questions in the natural world. And the way scientists do that is the way we use our common sense in everyday examples. It's just they have to be more careful about it because they're looking at things that are very small or very far away or happened a long time ago. And so they have to infer several steps of cause and effect. They're not just looking at something directly. But other than that, what they're doing is no different than we do in our everyday life. And so if there is a designer God or designer aliens that left their imprint on Earth by doing things, we can figure that out. And the trick is to say, okay, well, we know things are going to be complicated, whether evolution occurred or whether a designer occurred. But there's a lot of ways to be complicated. Rocks are simple, and yet you can look at rocks and see a lot of information on how they came about. Living things have a million times more information. So there should be things you could say where if they were designed, we'd expect this, but if they occurred by natural processes, we expect that. There should be many cases where you can do that.
Yeah, I agree with that. I agree with that. So,
Well,
Rod, thank you so much for coming on. There's been somebody waiting backstage, so I'm going to let her on. And and say goodnight to you. Did you start your channel? Do you want to tell people what your channel
No,
name is? Not
no,
yet?
I'm still
Okay.
figuring out how to use the programs and all
All
this
right.
stuff. It's a real hassle.
All
And
right.
so
I'll help you.
I'm going to
We'll sit
stay
up
here
and
and
talk and
read.
I'll help you.
All right,
Okay.
that'd be nice actually. I'm going to stay
Okay.
here and read all the nasty comments about me. So, all
Oh,
right. All
nah,
right.
don't do that. Okay. Good night, Rod. Thank you.
All right. Well,
Whoops. Sorry.
I-
What?
I'm just going to say I'll be in the chat, so I'll see you.
Oh, okay. Great. Thank you. Hey, Brenda.
How are you?
Good. How are you? It's telling me you're audio only. Is that the way you want it to be?
Yeah, I turned off my camera, if that's okay with you.
Oh yeah, that's fine. I don't know why it's doing this, because usually it at least shows people's little avatar, but mine is not showing that. It's not showing your avatar. So let's see. Yeah, did it bring you on? Okay, good. Okay.
Okay, well, it changed. Whatever.
I like that better because it changed. That's not your avatar that you use?
This is what happens when I turn the camera on and off.
Okay.
And
okay, well,
I don't know.
I like it this way if it's okay with you, because I feel like I'm talking to myself when there's no one on the screen.
Okay.
Is that okay?
Yeah, that's fine.
Okay, so glad to see you.
Yes, it's nice to see you again too. For the audience, Rebekah and I have known each other for a while. We go back. We haven't had a lot of contact recently, but Rebekah was hanging around certain people that I know, and she's a very interesting person. I like her. She's a good person. She's just poorly misguided about evolution.
Well, why don't you tell me how, Brenda? And yes, I want to say Brenda has been a good friend. I've enjoyed Brenda. She's always been a fun person to talk to. And we go back on my religious channel for probably, I think now 5 years. So
yeah, something.
Yeah. Okay, tell me why I'm wrong.
Long, huh?
Yeah, it has been 2021.
Wow.
Yeah. So tell me what makes me wrong about evolution? What makes evolution true?
Well, what makes evolution true is the evidence, right?
Okay.
Because you have a hypothesis. You have a hypothesis, and you compute the consequences of your hypothesis, and then you go out in the world and you look and you check it, right? So one of the things that and of course we don't prove anything in science. Science confirms hypotheses. It cannot logically prove that any hypothesis is deductively true. We can only say it's probably true to a high degree of probability or less, for instance. So one of the good evidences for evolution is the fossil record, and the fossil record is in a particular order. What they call the fossil column, the geologic column, right, is in an order. And if we found, for instance, a common phrase that is used, if we found a rabbit in the Precambrian geologic layer, that would be strong evidence against evolution, right? And evolution is just the theory that species arise by changes over time, right? They evolve, they're small changes, and those changes accumulate until a population of individuals becomes a different species. And there's different ways that can happen. It can be radiative evolution, it can be convergent evolution. You can have a central population that stays one species, but those that migrate to a different area become another species. There are ring species where, and typically it's isolation. Living in isolated in niche environments, you'll get a lot of speciation. You have to have some kind of environmental pressure that will cause reproductive uh, favoritism for one trait over another. And that's what causes evolution. And all the evidence that biologists have investigated so far confirm all of the predictions of evolution. Okay.
Well, I think you're mistaken about that, Brenda. And so I will say that I think, the fossil record is actually a problem for evolution. Although I will say the ordering, the overall ordering, it follows the evolution story. But I'm not sure which came first, us finding the fossils or the evolution story. Do you know much about that?
Finding fossils came first. People thought at first that these bones they were finding were monsters that are mentioned in the Bible. But eventually it became apparent that this didn't work. And it was finding fossils that eventually accumulated to such a point that people, along with other biological evidences, came up with a theory about evolution. So I think it was finding fossils came first. That's the evidence. People had different theories until they settled on a theory that actually worked.
And I guess what I mean specifically is, do you know how much we knew of the fossil record before we developed the ideas?
Yeah, very little. People had odd ideas. They didn't know much about. They had to figure out geology. Geology itself was a problem, right? People didn't know about tectonic plates. They didn't know about a lot of the processes that produce the rocks that they find. They would find rocks and stuff, and they wouldn't. This was long before we even had chemistry to figure out what they were. It took a long time to figure out how rocks are formed, what are the different processes that form them, how can we account for the different layers that are observed, the geological layers, and then the fossils that are discovered within those layers.
Right. Okay. So although I agree that, like, overall, the fossil record, it follows according to the evolutionary story. I'm not clear, and this is something I want to learn more about. How developed, like, were there a lot of predictions about the order that we would find things before we found them?
I don't know.
So that's the part that, yeah, I'm not sure about, because
history.
Yeah, and I mean, it'd probably take a little bit to actually figure this out. It would take a lot of digging. But like, that would be important to know, because, if we had already found the general ordering of the fossils, then it's easy to develop a story based on that, right?
Well, I think people did. It's just that they'd make mistakes. They would have theories, and they wouldn't work based on, because people are always looking. They're always, digging and finding new things, and new discoveries can overthrow previous beliefs. So we used to believe that the Earth was the center of the universe, and that the sun revolved around the Earth. It doesn't do that, right? We discovered that it doesn't do that. It took a while.
Right. And so I still think, though, if we put aside, the potential that the overall ordering of the fossil record fits the evolution story, the fossil record is still a huge problem for evolution.
How so? What is the problem?
The problem is that we have the sudden appearance of forms is what characterizes the fossil record. So
no, they don't. They appear gradually over millions of years.
Well, what are you specifically referring to? Because I'll give you some examples. Okay.
entire geologic record. It covers about what, I don't know what the exact number is these days, 3.5 or close to 4 billion years. That's a long time.
Right. But what characterizes the fossil record is extinction, right? Like organisms
Yeah,
that,
yeah.
right.
99% of all species
Yes.
are extinct.
So, right. But what we see in the fossil record is the sudden appearance of complex features in life. So you have,
No, we
500.
don't. That's just, we don't though. And
Okay.
they take place over millions of years. The fact that it looks like that because you find it in a layer, but the layers of rock and stuff and sedimentary layers, these take long periods of time, right, to be deposited, right?
Right. But let me give you an example so you'll know what I'm talking about. So if we look and we see a trilobite from 500 million years ago, it has complete complex eyes. Okay. So, and we don't see any slow development of eyes through the fossil record for trilobites. We see the sudden appearance of eyes.
Okay.
So there was no millions of years of developing it. And that's a problem for evolution.
The eyes, even Darwin gave a very plausible explanation for the evolution of the eye. It's very simple, right? Right?
No,
You're
it's
familiar
not
with
very
that.
simple. It's
You're
not
fam-
very
You're not familiar with Darwin, just Darwin's explanation for the eye, how an eye could evolve.
I mean,
Not that hard, right? You have a patch.
No, it is very hard. It's very
How
hard.
so? What's hard about it?
Well, okay. I mean, but all of the parts that are required for the eye to work together. I mean, think about it. Like, I mean, if I asked you to build an eye, like, can humans build an eye?
Yeah, they're called cameras.
Right. Okay. But even a camera is not as sophisticated as your eye. And
Yeah.
but what you're talking about, so like if we build a camp, like, do you see a camera being able to come about by natural chemical and physical processes?
Well, the claim isn't that one day there was nothing and then there was a human eye. That's not the claim.
But the claim here that I'm making is that in the fossil record, we see the sudden appearance of complex eyes. And so it is like there's no progress of slowly building up the eye over time in the fossil record. So you have at 500 million years old.
Soft tissue isn't going to fossilize. I mean, it feels like that you don't actually know what Darwin wrote about it. It's very simple. You have a patch of skin which is photoreceptive, has photoreceptor cells on it. It can become a depression, and then you can have different features. And at each stage, it's functional. It performs a function for the organism that enhances its ability to survive and reproduce. That's all that evolution needs. And so my understanding is that scientists and biologists say that the eye has evolved about, I think the number is 42 different times, completely separate lines of evolution, right? So, and that's because it's very useful to be able to see in order to survive.
Right. But okay, well, there's so much there that we need to talk about. Okay. Yes, Darwin described a process. Was his process that he described a scientific process? Like,
yeah,
and there have been articles even, in the last 20, 30 years that have been written on this, trying to show the development of the eye. And I have a video on this, Brenda. So I hope you will consider watching that video.
I'm subbed to your channel, but I haven't watched very many of your shows.
Okay.
Well, I sub to more creators than I watch.
Yeah, I understand. Well, I would hope that with regard to the eye, you will watch and see
Yeah.
why that simplistic explanation
I'm just
that Darwin offered, and even the more complicated explanations that are being offered in scientific articles today are not sufficient. And in fact, they are quite preposterous as far as their proposals for the development of the eye.
what is it that makes them preposterous other than your incredulity?
Well, there are some things that we should be incredulous about, things that don't match up with our scientific observations, right? So
No,
what
that's
I'm
not true.
going based on is our scientific observations about what mutations and natural selection are able to produce, right? Like, and so this is, and unless I'm going to pull up my whole slideshow that's from my eye video, I'm not going to be able to lay it out very well right now without giving you some visuals and things.
I just
But
don't
there
see.
are two other people waiting backstage. So
Oh, okay.
yeah. So I don't want to do a presentation on something that I've already done. But like, if you watch my video and then you want to have, we can set up a discussion and you can refute my video.
What is
And
your explanation?
my explanation,
How did trilobites?
created.
How did God created the trilobite
Yeah.
eye 500
Yes.
million years ago? So
I
believe
didn't
in
say if
deep
I don't
time?
agree with the time periods. No, I don't agree with time periods, but God created the trilobite eye.
So you don't believe in physics?
Okay.
Because the deep time is based in physical reality, the reality of radioactive decay, right? If you're going to deny that, you're not really even in the ballpark anymore. You're
Okay,
close
well,
to being a flat earther.
Okay, well, this is taking it to radioisotope dating. You know, if
Right.
I'm happy also to do a talk with you about radioisotope dating, if you want to talk about that, right? Because there's lots of problems with radioisotope dating.
There actually aren't.
Okay,
There
so
aren't. I've
okay,
listen,
so if we find
I debated creationists when I was 19, right? No one has ever brought up an argument against radioactive. How can you? Because this is hard science. This is not biology. This is hard science. We know, right, how radioactive isotopes decay and how long it takes, what their half-life is. We know that. We can date things accurately with that, right? And so to deny that is like denying that the Earth revolves around the sun.
Okay, so if
It's
we
hard
got a
physics.
volcano, if we had a volcano and or a lava flow that we tested the rocks and we got a date of 22 million years with potassium argon dating, would you accept that as an,
No,
that is
because
a
that's
fact?
a misuse. That's a misuse of that metric. Creationists do this
How
all
is
the
that a
time.
misuse?
They misuse a carbon dating, right? Carbon 14 dating. They misuse it. They apply it to things for which there's no good reason to apply it to. So carbon dating the magma that comes out of a volcano is just insane. It's just insane. It's not using the instrument in the appropriate way.
Okay, I'm talking about scientists. I'm not talking about creationists. I'm talking about secular scientists who have attempted to use potassium argon dating to date various things, and they end up getting dates that are way off of the actual date.
Yeah. Oh, number one,
So yes.
I think that as usually happens in this case, you have to show that they were actually scientists, because typically what happens is they aren't actually scientists. They aren't experts in this field. They are some creationist scientists from the Creation Institute, right, who have an agenda, right?
Okay. So argon 40 excess in submarine pillow basalts from Kilauea volcano, Hawaii. Okay, so this is an attempt to radioisotope date. It's by secular scientists, right? And it didn't work out. Okay, so they got a millions of years date from potassium argon dating for a volcano that they actually know the historical date from.
Yeah.
Okay,
So why would
so
you
this
do
isn't
that?
creationist. This isn't
Why would you?
creationist
Why would you do that?
because they're scientists and they're making an observation. They're trying to test
They
the date.
know. They know when it was, how old it is.
Okay, because they're testing their potassium argon dating. Okay, and
Yeah.
they get the dates of millions of years old. So this is telling you there's something wrong with that dating method.
Well, there's something wrong somewhere. Right?
Okay.
We have to look at the study. So if I witness a car crash and I inspect the car and I find in it a clock that says it's 3 days old, the car crash wasn't 3 days old, right?
Okay, but do you understand? I'm not picking out what creationists did.
No.
I'm giving you a secular paper. So I'm trying to combat the charge. I'm trying to combat your accusation that creationists are misusing the dating method.
I think that's like I have a balance scales, and on my balance scales right now, the biggest weight is this is biased in some way by people who set out to prove something. Right?
Yeah, and I agree. Radioisotope dating is one of the challenges for my view of creation. Okay, but this is what I notice often when I invite people to share evidence for evolution, they can't share evidence for evolution. Instead, they have to turn it to something for young Earth creation, right?
Well,
like they have to challenge young Earth creation instead.
Oh, okay.
So,
well, I can give a different, which is simply genetics validates evolution, because we can trace ancestry of biological organisms back way back. All of life on Earth is related to each other, and the genetic record that animals have, inside of them, shows that all of life on Earth is related to each other.
Well, I disagree with that. So, and that's a very big topic. So, I mean, if you want to bring something specific, that's what I'm kind of looking for is specifics.
Do you have a link to that paper about radioactively dating? Well, what did they debate? What did they date? Was it a magma or?
I don't want to go back to talking about radioisotope dating because like I said, I'm happy to do a show on that another time, but I am trying to keep this on the evolution topic.
Well, so, the prompt is what makes evolution true. I gave you the answer, one of which is genetics, one of which is how all of life on Earth is related to each other. The other is the geological column validates the evolution. Our theories of evolution. You've brought up whataboutisms, and I don't think whataboutism refutes anything. I would like a link to that paper to see what that was actually about, because my experience with debating people, different types of people, is that very often they misread it, they don't understand it, or the people in it do not have the credentials that they claim to have, or that the paper doesn't say what the person thinks it says. That's my experience, and so I'm skeptical. And I would like to. Do you have that paper? Can I see it?
Yeah, I have it right here, and I can send it to you. I don't have the link handy. I will read out the title, and you can look it up. Argon 40 excess in submarine pillow basalts from Kilauea volcano, Hawaii. and so basically their conclusion from this is that they can't use potassium argon to date certain rocks, right? And but do you see how it's all wrapped up in their assumption, right? That like, so if we get the wrong date of a known rock, then it doesn't work.
Oh,
Okay.
well,
So
would you look at that? This trapped gas originates from the deep mantle and does not result from in situ radioactive decay of potassium, making these rocks unsuitable for standard potassium argon dating methods. There,
Brenda,
that didn't take long.
Brenda, do you understand though, whenever they get a date they want, they keep it. If they get a date they don't want, they find a reason to throw it away.
This isn't about wanting or not wanting. It's one that is not suitable, right? Because the potassium argon comes from deep in the mantle. It is not the result of radioactive decay, because that's how radioactive dating works. You have a known amount of a radioactive isotope, right? And then it decays. We know the rate at which it decays. You measure the daughter products, and then you can know how long that piece has been there. But if it came from deep in the earth, then that nullifies it. It's no longer a dating method.
Okay. Debunked. Well, like we could have a very big conversation about this. Okay.
No, we just did, and you lost.
Okay.
You gave me the link to it, and you lost.
I didn't lose. I'm trying to point out to
what you say. Okay. The summary just debunks your claim.
All right. Well, look, like I said, I'm happy to have a longer conversation about it. But
I'm sorry for getting agitated. I'm sorry for getting agitated, Rebekah. I love you. You know, you're a good person and stuff. I get animated in this.
I can see.
And it's not personal, right? Okay.
All right. But your other evidence for evolution that you gave is mostly religious. We can talk about it another time since you're
agitated. I gave no religious arguments.
Okay. Well, I think they are. And I've made
I don't think you
several
know what
videos on those,
then.
but I think there's 2 more people waiting backstage. So
okay,
okay. Thanks for coming on, Brenda. All right. Hey, Dr. Dan, you're on.
Hello, can you hear me okay?
Yep.
All right. So I know you've been going a while. I don't know when you started, but it was significantly earlier.
Yeah, it's almost 2 hours. So maybe if we can like spend 15 minutes or less.
Let's be real quick. I've been doing a lot of reading and thinking about mitochondrial DNA lately. So what I want to put forward for you is just real quick how we know that mitochondrial DNA necessarily indicates an old Earth consistent timeline to the mitochondrial most recent common ancestor rather than a recent mitochondrial most recent common ancestor. There's a bunch of ways that we know this, but we can just do one really fast if that sounds good to you.
Sounds good.
Let's do it. Okay. So just broadly speaking, overall, when you look at a multicellular organism, there are 2 kind of buckets we can put mutations in, right? There are somatic mutations and there are germline mutations, right? So somatic mutations is most of your body, and then germline are the reproductive cells, right? And the somatic mutations, those can never be passed on to offspring, right?
Yes.
Yeah, so your skin cells, your muscles, your brain, all those mutations can never get passed on, right?
Correct.
The studies that young Earth creationists will cite to get you to a recent mitochondrial most recent common ancestor, those studies are pedigree studies. Yeah, they're Parsons, Ding, there's a whole bunch. But these are pedigree studies where you look at parent, you look at child, you count the differences, that's a pedigree, you calculate the mutation rate, right? That's
Yep.
I know we've talked about this before. I want to make sure we're on the same page, but that's how these things work. So specifically, those studies and the 2 main ones that you see from young Earth creationists, and I don't want to put words in your mouth, but the ones that you typically see from like I'll say the professional young Earth creationists It's the Parsons study from like I forget the year, 97, I think it was. And then there's the Ding 2015 one, which is the one that Nathaniel Jeanson uses. Those all look at parent to child transmission events in terms of the mutation rate. They look at a parent, they look at the child, it's the mother necessarily because it's mitochondria, and they look at the child and they count the differences up, and that's the single generation mutation rate, right? Are we on the same page there? That's how they do it.
Yes.
Yeah, and then they take that, and this is like Jeanson, this is just textbook Jeanson. You take that single generation rate and you put that backwards linearly in time, and you can calculate, okay, it's this many mutations per generation, we need to account for this many total, so just do the math, and it's X number of generations in the past is your most recent common ancestor. Yeah?
That's generally, yeah.
Okay. And so those studies, they represent single transmission events, right? Parent to offspring. That's a single transmission event. You have a kid, there's differences, those are the mutations. Now, in those studies, the samples that they're taking, those are either blood samples or cheek swab samples, where you do this and you sample sequence the DNA.
Right.
Right. Blood cells and cheek cells are somatic cells. They're not germline cells, right?
Yes.
So if we're counting the mutations in the blood cells and the cheek cells, those mutations can't be transmitted to offspring, right?
Right.
Right. So those mutations are not relevant to mutations that are going to build up over time because they can't be transmitted, right?
Okay.
Okay. Which means that if you're going to take, for example, the Parsons study from 1997, the one that we always hear about, the one that, the FBI, uses the mutation rate, whatever, where they actually say in the paper that if you take this rate at face value, you get a mitochondrial most recent common ancestor like 6,500 years ago. You can't do that because those mutations don't actually get transmitted, right?
Well, I'm not sure. Like, I mean, I agree with you that generally somatic cells they're not going to get,
well,
somatic
not generally,
mutations are,
like,
okay,
absolutely.
Somatic mutations are not going to get transmitted, right?
Okay.
But I don't know what their reasoning is for why they're doing that, right? Like, these aren't creationist papers.
Right.
Would you agree? Okay, so did Parsons have a reason? And I mean, it's not limited to Parsons, right? I have a whole stack here of, mutation.
There's a bunch. Yeah.
Yeah.
And my point is, these are either I think entirely they're blood cells or they're cheek swab samples. Those are the types of sampling that they're doing in these pedigree mutation rate studies. Yes?
Right. So
Right.
are you contesting? Yes. Are you contesting the findings of the papers?
Nope. I'm contesting
Okay.
the utility of extrapolating those findings back in time because those mutations cannot be inherited if they are somatic, which blood cells and cheek cells are somatic.
Okay. Have you written any letters to the editors about these papers that are
That's
being
irrelevant
used?
because the authors are not doing what creationists do with the numbers.
So but the authors are looking, the reason they're doing it is to see what the mutation rate is, correct?
Right. They're looking at the mutation
Okay.
rate, not calculating the time to most recent common ancestor. It's creationists that take those numbers and misuse them to calculate the
Okay.
time to most recent common ancestor. Yeah.
So Parsons didn't do most recent common ancestor?
They said
He
if you
specifically
take
did.
our numbers and do it,
Yes.
this is the number you would get, but that's wrong
Right.
for XYZ reasons.
Right. I mean,
Right.
of course,
Thank you.
because he's an evolutionist, right?
No.
So he's not going to agree with most
Nope.
recent common ancestor being
See,
6,000.
that's where I get frustrated because we just went through the logic of why you
Okay.
can't do that, and you agreed with every step, didn't you?
But I'm
Hang on,
I'm-
you agreed with all the stuff I said, right?
agreeing with your logic sounds
Thank you.
good. But the
Great.
part I'm not agreeing with is I don't know why these papers, the secular papers, are using that methodology if it's wrong for calculating the current mutation rate.
I can
I'm
tell
not
you.
saying extrapolated. I'm saying why haven't you written any letters to the editor complaining about their methodology?
I can
Okay.
tell you. It's
Go ahead.
because what you just said was wrong. It's you said, why haven't you written any letters explaining why their methodology is wrong for calculating the mutation rate? The answer is it's not. what the problem is when people take that single generation mutation rate, which we agree overcounts mutations because it includes somatic mutations, and extrapolate it back in time as though those mutations can be inherited. Now, the authors are not doing that, right? Parsons doesn't do that. They say, here's the number you would get, and that's silly for all these reasons. Ding doesn't do that. And a bunch of years ago, when David Neff actually emailed Ding, the author of that 2015 paper, and said, did you remove the somatic mutations? His answer was no, right? So the papers, I think, are generally fine because they're reporting the single generation mutation rate. The problem comes, so there's no reason for me to like email the editors and say like, hey, this paper is wrong, right? It is what it is, it's fine. The problem is in the misuse of those numbers because you're taking somatic mutations, which we agree can't be inherited, and extrapolating that rate backwards in time infinitely to the most recent common ancestor, right? That's the problem. Now, the biologists writing these papers aren't doing that, right? Nathaniel Jeanson is doing that. But like, I can't write a letter to Answers Research Journal because you can't get published in that journal unless you sign their statement of faith, right? So I can't do that. So that's the answer to your question.
Okay, great. Now, how does that help evolution? Because this stream is not about complaints about what creationists are doing with research. It's about what makes evolution true. Where's the evidence for evolution? I'm
so happy you asked, because the flip side of that coin is the evidence for evolution, because you're a young Earth creationist. We've talked about this before, right? You're in the young Earth creationist camp, right? And so if I'm providing evidence that the mitochondrial most recent common ancestor existed 60,000, 100,000, 200,000 years ago in the past, that's evidence for evolution in contrast to young Earth creation. You haven't provided
that evidence, though. You've told
I'm sorry,
me
say that. Sorry, I didn't hear you when you said that.
You haven't provided evidence.
Oh, I just did. And we agreed that you can't use those rates to calculate the time to most recent common ancestor. That's the evidence.
Okay, so what you're doing is you're taking an argument against an argument that young Earth creationists are using, right?
Yes.
But how is that evidence for your theory? Yeah, where is your mutation rate? How are you calculating that, where's your actual beef? Where's your meat? Rather than just complaining about a methodology that creationists are using.
So I have two answers for you, but before I get to them, I just want to make sure we're on the same page. You agree with everything I've said in terms of the consequence of using somatic mutations and the inappropriateness of extrapolating somatic mutation rates back into the past, right? We agree on that?
Okay, I'm agreeing with the somatic mutations are not getting passed on in the germline. Great. Okay.
So therefore we can't use that rate in the past, right?
That I don't know about, and I've learned my lesson with you that I need to fact check you. Okay. So
wait, are you calling me a liar? When did I lie to you?
I didn't say you're a liar.
That's what it sounded like. What have I said to you that's wrong?
Liar. I'm saying that a lot of things that you present as this is true, turn out not to be true. I'm not saying you're lying.
So give me an example, because I really try hard to not say things that aren't true, and I've actually got several videos on my channel of like correcting myself when people have pointed it out. So please give me an example of something I've said to you that's wrong.
Look, there is a video that we did together on my channel that I have talked to you extensively about. I've tried to show you how you're wrong. Other people have even taken up your arguments and tried to show you how you're wrong. And we still haven't been able to get you to admit it. Okay. And I would prefer not to hash the entire thing out right there, but you're asking me for where am I getting the idea that I have to, look into what you're saying. And that's one of the instances where I have to look into what you're saying. And another one is your video about blood on, you did a video on blood types and how, there's no room for like the blood types, the variation, the alleles, the number of alleles that we have.
Oh, the created heterozygosity video, the recombination rate. Yeah. Okay. Yeah, those numbers are well documented. Yeah.
Okay. Well, that turned out to be a problem.
Well, let's talk about that for a minute then, Rebekah, because the two numbers that are relevant there are the number of alleles. Actually, it's three numbers. It's the number of alleles that exist currently. It's the number of alleles that could exist at creation, which is 4. which we agree on.
Right.
And then it's the average recombination rate, which is one crossover per chromosome per arm per chromosome per meiosis. Those are the only relevant numbers there, and none of them are wrong.
Okay. So are you saying we know the mutation rate?
No, that's irrelevant. Mutation
Okay.
rate is irrelevant to that question.
But it is not irrelevant to the thing because I asked you, are you calculating it considering mutations? And you said no.
Yeah, because I was showing that the creationist argument is wrong, and that comes from Dr. Nathaniel Jeanson, where he said over 99% of the diversity is due to recombination, not mutations. So if you want to take my numbers and adjust them by 1%, feel free to account for mutations.
Okay. Well, anyway, I don't know. I don't have this has been probably a year ago that I watched the video, so I would have to go back and see. But the whole point is that, you asked, do I think you're lying? No, I don't think you're lying. That would be very foolish, with your profession and everything to come on and specifically lie. But do I think you're wrong about things? Yes, and quite a few things. So, I mean, I'm not calling you a liar. I'm just saying even very smart people, even very educated people can be very wrong.
Okay.
So
let me just, before we go, so I said there were two answers to your question. I want to get to that. I just want to kind of recenter us before we do that real quick. We agree that somatic mutations can't get passed on. And we agree that single generation pedigree studies capture somatic mutations in their data, right? We agree on
yes.
that. Okay,
Yes.
great. And the thing that you're not willing to agree on is that therefore we cannot extrapolate that single generation rate backwards in time, right?
Okay, let me say this. I think there are a lot of factors that can affect mutation rates over time, and that those need to be accounted for. And they could affect them in either way, ways that could be beneficial to creationists, ways that could be beneficial to evolutionists, right? So we can suggest different factors that could affect mutation rates over time. So do I think it's a mistake to extrapolate over time, large amounts of time, and assume that a mutation rate is constant? I do think that's a mistake.
Great.
Where
Thank
I'm not sure about what you're saying is I'm not sure what's going on with these papers and why these authors are thinking, because a lot of what they're doing is trying to calculate mutation rates, right?
Which is different from substitution rate, which is different from time to
Okay.
most recent common ancestor. These are three different
Okay.
things that I think are all getting conflated here. And calculating the mutation rate is very different from calculating when the mitochondrial most recent common ancestor existed, right? Those are different things. They're different
Okay.
calculations.
Yes. Yes.
Right. And
Right.
that's why these authors are doing what they're doing. They're looking at things like, for example, mitochondrial diseases in Amish populations and the mutation rates and the rate of these diseases. Like that's literally something that one of these papers deals with. The time to most recent common ancestor is irrelevant to that question.
Right. And so, but the point is that I don't know why they're using somatic mutations and why they're okay with that.
I just explained it.
All you're doing is saying they're not using it for most recent common ancestor.
Right.
And I agree that is not what they're using it
Because they're
for.
looking at mitochondrial diversity within a family. Yeah.
Okay.
That's what they're doing.
So, but the point is you aren't offering evidence for evolution.
And that was the second
thing. Okay. So,
Got you covered.
Okay. What is your evidence for
So
evolution?
the evidence for evolution is the correct way to do these techniques, which I know calibration is a dirty word in creationist circles, but what you do is you calibrate the rate of mutation accumulation based on past ancestors that are anchored at a known point in time, right? So instead of looking at common ancestry with chimps, for example, which I know that's a no-no, you can't assume evolution to prove evolution, right? Forget that. We can just look at things where we know when they happened in time. So we know, for example, when the island of Tristan da Cunha was settled, right? We know when that happened in time. That's not something we have to debate, right? It was like 1820 or 1816 or whatever it was, right? We know when that happened. We know when, I forget the relative's name, but it was Richard III of England. It was like his sister or aunt or whoever it was. I forget her name. I forget who it was. I'm not going to embarrass myself by trying to remember this person's name in the 1400s. But we know when this person existed, and we know when they had kids, right? Like this is a royal family with like a documented history, right? We know when these things happened. I don't think anyone's debating like when these historical events happen. We know when, for example, Iceland was settled, or Madagascar, or the Canary Islands, or Vanuatu, the Norfolk Islands, right? We have a bunch of these examples where we know when this thing happened in history, right? We can agree on those events.
Yes, but is this going to get to evidence for evolution in the next 5 minutes?
I'm getting there. It takes a minute,
I'm ready to close it out.
Yeah, so what we do is we know when the common ancestor existed, and we can look at the mutation accumulation since that common ancestor, right? We can look at since the 1400s, how many mutations? We can look at since the 1800s, how many mutations? We can look at since, Iceland, 1,000 years ago, how many mutations, right? So we don't have to infer a rate of mutation accumulation. We can directly measure it over decades and centuries based on events with known points in the past, where we know when that common ancestor existed, right? That's a thing we can do.
Yes, and I know you love that Tristan da Cunha example because it fits the evolutionary rate.
Well, I love it because it does the math correctly, and the fact that it fits the evolutionary rate is the cherry on top, but the real draw is the correct methodology. So my point here, well, hang on, because it's not just the Tristan da Cunha one. There's a bunch I just mentioned, Norfolk Islands, Richard III, there's a bunch. And when you look at the mutation accumulation rate over time, what you're doing is you're necessarily looking at mutations that occur in the germline. They're heritable, right? Because you're looking over many generations, right?
Yes.
So they have to be heritable mutations.
Okay, so...
Right, well, hang on, do they have to be heritable to occur over,
Yes, but they...
Yeah, easy.
What are they doing different in those tests? What are they testing different? And so you're saying they're not testing the somatic mutation?
Yeah, because when you look over multiple generations, you weed out somatic mutations because you lose all of them in the transmission, right? You lose all of those in the multiple events, right? So if you go back 300 years, the differences you can document in the descendants from that common ancestor, those differences necessarily have to be germline differences because they've accumulated over many generations. So any somatic mutations that happened in there are gone. So they have
You're
to be
just
germline.
destroying your argument from earlier because your complaint was they're using blood, they're using things that are somatic mutations.
And over one generation, exactly.
Okay. But even the Parsons paper is not over one generation.
It is. There's a single event where it's a triplet, where it's grandmother, mother, daughter. There's a single Amish triplet in that paper. All the rest are just mother, child. And even in the triplet example, they actually measured from grandmother to mother and then mother to daughter. They did it on a single generation basis. So no, the Parsons paper doesn't do what I'm saying.
Okay, how about the Helgeson paper?
The Helgeson 2015, that's a Y chromosome paper. That's not mitochondrial DNA.
Hold on, let me see.
Anyway, my point is, these are multi-generation studies which weed out somatic mutations because a mutation in the, so I can't read, it's too small. I can't read it.
Okay, it's Helgeson 2024 mitochondrial DNA. So
there's no Helgeson. Helgeson's not the first author on that paper. Helgeson's
you're right, it's Arna de Tour. It's Arna de Tour.
The
last time I told you Arna de Tour, you said, I don't recognize that name. And then you said later, oh, the Helgeson paper.
Yeah, because that was we switched to Y chromosomes. Yeah.
Okay.
It was,
I chose Helgeson this time because I know it's the name you recognize.
Well, you always name papers by the first author in the year. So if you say Helgeson, I'm going to go to the 2015 Y chromosome paper. Anyway, it doesn't matter which paper you pick, as long as it's surveying with a known ancestor more than one generation in the past, that's good because you're weeding out the somatic mutations. Do you understand that that's the case, right? You can weed out the somatic mutations by doing multi-generation. Great. Now, the key thing is when you do this, when you look at the rate of accumulation in the multi-generation pedigree studies, which, to be clear, are directly documented, directly observed. There's no assumptions here. We know the time in the past. When you do that and you do the take the rate and calculate it backwards in the past, you get the old Earth timeline. The minimum number you get on the lowest end of the confidence interval is 60,000 years ago, 10 times beyond the young Earth timeline. These are directly observed. These are directly observed rates of mutation accumulation that allow you to account for the existing divergence by weeding out somatic mutations, which we agree can't be transmitted, so you have to do that. And when you do that, you get a number at a minimum of 60,000 years ago, and the consensus range is 150 to 200,000 years ago. And that's the evidence for evolution.
Okay. And let me just say that I agree that those papers you picked that's the numbers they would show. Okay. I'm agreeing to your papers.
Thank you.
But my complaint is that you are cherry picking, because there's a whole bunch of other ones that are not based on one lineage, like this paper. Okay. If you can see, you can see the lines. It is not just one generation. Mm-hmm. Okay.
And so what's the mutation rate in there?
It'll take me a minute to look because I don't have these memorized. Okay. It's been quite a long time since I looked at this. But
it's like one mutation per 30 generations, give or take?
It probably, yeah.
Okay. So
okay, it looks like, wait, hold on. I'll try to find a quick number for you, but go on.
I think it's about one per 30. It's like 30 something. It's one mutation per 30 something generations, if I remember that one correctly. Right. And let me just do some quick math here, because you have 120 mitochondrial differences in the two most different humans from each other. Right. We can just measure that. So if we have 120 differences, right? I'm doing math on my phone right now. 120 differences times 30 mutations or 30 generations per difference, right? One mutation every 30 generations. Okay. Times, what do you want to use for generation time? You want to go with 20 years?
It doesn't matter.
Let's go with 20. It's probably the average historically is probably slightly above that, because you have to account for child mortality, but let's go with 20 years.
I'm not worried about it either way. Give them 20.
So 120 differences times 30 generations per difference, times 20 mutations or 20 years per generation. And then we're going to divide that by 2, because you have to do each lineage, right? You have to, you can have, if you have 120 differences, you could have 60 of them here, 60 of them here. So you divide that number by 2, and you get 36,000 years, 6 times the young Earth timeline.
Okay, you think that this is a bust because you think I'm absolutely okay, let me ask you this. So, because you're still not showing evidence for evolution. Yeah, I'm fine with that number. Actually,
so as a young Earth creationist, hang on, I want to be clear about this. As a young Earth creationist, you're okay with mitochondrial Eve existing 36,000 years ago. You're good with that?
No, I'm not. No,
okay, because that's the paper you just cited.
I'm not okay with that. But remember, earlier you were saying we can't extrapolate back into the past. But
I know, because it actually slows it down. Yeah, there's reasons it actually slows more than that. You're right. But it's not for the reason you want. Yeah.
Well, we can find reasons to slow it down and reasons to speed it up. But what I would say is 36,000, it does not fit the evolutionary timeline, right?
Yeah, it does. It's in the same order of magnitude. Yeah, it does actually.
36,000. Okay, so when are you saying our most recent common ancestor was?
The most recent common ancestor is 60 to 200,000 years ago. And if you do part of the math, right, if you ignore purifying selection, which we haven't even talked about, you get 36,000 years. Now, purifying selection is going to slow that down even more, right? Because purifying selection reduces diversity, right?
I'm not going to.
You don't agree with that? You don't think?
I'm not going to have a long argument about this, because we've already said mutation rates can alter, right? Okay.
I haven't said that. Have you?
Yes, I have. And you
I
said
haven't.
that.
No.
You said we can't extrapolate it back into the past.
Yeah,
so
mutation rates, the rate at which the differences occur is approximately constant. The rate at which they build up, The probability of fixation of a particular mutation declines over time. Yeah. So you end up with a curve where young mutations are more likely to be present and old mutations are more likely to be lost. Yeah. That's different from the mutation rate changes over time.
Okay, look, and I want to close it out because, look, I've been going for more than 2 hours now. It's 2 hours and 20 minutes. But I just want to say, for me, like 36,000 is pretty close to the young Earth timeline.
It's 6 times the young Earth timeline.
Okay, and it's also about 6 times the evolutionary timeline.
Nope.
I know you're.
Nope. It's not. It's like 65% of the of the old Earth, right? It's it's way closer.
I thought okay. Well, anyway, I'd have to look into that more, but I do think that what we would expect, right, is like for the evolutionary timeline, we would expect one mutation every 600 generations, right?
No, you're conflating mutation and substitution rate. Those are different things.
Okay.
So when you use your pedigree studies to calculate the mutation rate, you get mutations fairly rapidly. But the rate at which those mutations will achieve fixation in a given lineage is a lot slower due to factors like the strong purifying selection in the mitochondrial DNA. So so that's the difference, is that we can directly observe a rapid rate of mutation occurrence, and we could also at the same time directly observe a very slow rate of mutation accumulation. Those two things are not in conflict with each other, and it's not that the rate changes over time, it's simply measuring two different things.
Okay, well, the argument that I'm sure you're aware of is that in some areas of the mitochondrial DNA, the substitution rate equals the mutation rate.
That is wrong, because the mitochondrial DNA is non-recombining, because it's a haploid circular chromosome. It's non-recombining. Right?
But the substitution rate is the mutation rate.
No, it's not.
Okay.
No, it's not.
Well, and maybe we should just agree to disagree on that. And honestly, I mean, you may think you're making a strong argument here. For me, I don't have a problem when I see the number 36,000.
That's amazing to me. That's great. If you want to acknowledge that the time to most recent common ancestor for mitochondrial Eve is 36,000 years, that's fantastic.
I didn't acknowledge that. No, I did not acknowledge that.
If you don't have a problem with that, that's fantastic. Thank you.
Okay. And you don't have a problem with that number for your
No, because that number is not accounting for selection, which is further going to drag it into the past, right?
Because no matter what you find, no matter what numbers you find, you'll find a reason that it's okay.
Well,
right?
Are you disputing that selection occurs on the mitochondrial DNA?
I'm not disputing that selection occurs.
Okay, great.
But what I'm saying is, no matter what we see, you'll find a way to make it fit the evolutionary timeline.
Then you should have no problem pointing out something I've said that's wrong.
Okay, well, and maybe I will take the time to look into it. But for me right now, you have not offered evidence for evolution. And my purpose is not really focused on defending young Earth creation. It's what I believe. It's a story I believe. I think there's good evidence for it. I do acknowledge that there are challenges to young Earth creation. So I'm fine with 36,000 years being a challenge, right? But it doesn't help the evolutionary story, right?
You say so.
Thank you for coming on, Dr.
Thanks
Dan.
for having me.
I'm going to take a few comments from viewers and then I'll turn it off. So take care. Good night. Okay, so I had some comments that came in the beginning. I'm not going to let anybody else on, but I do want to go back to these. So Science Rules, before the stream started, said a huge quantity and quality of conciliant positive supporting evidence gathered over the last 165 plus years shows the evolution of life on Earth over the last 3.7 billion years is true. Okay, I strongly disagree with this, and I invite people to bring their evidence. And I hope you noticed that we didn't really have any good evidence brought for evolution tonight. We had some religious arguments and some attacks on young Earth creation as usual. And in fact, I made a little thing. I was going to put this up, but I thought, well, maybe I should just leave it alone because Rod's already here. So I didn't put it up. But let me go ahead and put it up. These were going to be my predictions for the typical tricks that evolutionists do to avoid giving evidence for evolution. So they have a very hard time giving evidence for their theory. And so instead, they absolutely love to change the subject to young Earth. I'm a young Earth creationist because I think it's the best explanation that we have, even though it's very problematic. Like, there's a lot of problems and challenges to young Earth. But of all the different ideas that I've tried to think, would this work? Would this work? Young Earth creation seems to fit the best with scientific observations and scripture, even though there are some scientific observations that are difficult and challenging for it. But like I said, the typical tricks, we saw a lot of them tonight, is change the subject to something that's challenging for young Earth when you can't give evidence for evolution. The second thing that I didn't really see this tonight, but another little trick people like to do is a science terminology quiz. They like to come on and say, do you know the meaning of this? Do you know the meaning of this? And, I guess we had one guy doing, do you know the meaning of self-evident? Okay. So, and maybe I can't define self-evident. I don't know how to describe self-evident. I know what it means, but I don't know how to describe it. But I mean, that's not really what I mean, because usually it's more scientific terminology that people use. And then the final thing that they do is they bring evidence that relies on the assumption of evolution. They assume evolution is true. It relies on the assumption of common ancestry, and then they present evidence based on that. And that is what I see over and over again. That's why there's so few actual argument pieces of scientific evidence given for evolution in these streams that I do. And people use a lot of religious arguments even without realizing it. So anyway, let me go through a few more comments. Science Rules says, what would you accept as confirming evidence for evolution? I've already shown you the evidence that I have accepted as evidence for evolution. It would take me a little while to go through like a laundry list of what I, might accept, but I'm looking for evidence based on scientific observations. Tom says, submarines have engines and drive shafts like a 57 Chevy. Does that mean a 57 Chevy evolved into a submarine? Thank you, Tom. Great point. Evolutionists love to point to similarities and say, see, these similarities prove that it had a common ancestor. But what happens when similarities are found when they're not, they don't belong on the same tree? Oh, then it's convergent evolution. So evolutionists can explain any scenario. They have lots of little fun patchwords that they use. And convergent evolution is one of those. They just use that every time they need to patch over a hole or a problem in their theory. So that's very frequent. Let me see what other comments I starred here. Just wanted to say hello to God is Now Here. Good to see you. Good to see you, Peter. Thank you for everyone for all of your comments. Bill says, Rebekah is overlooking the science is based on explaining what we observe. We observe how DNA works and explain what we see. Yes, well, the problem is that we're not talking, I think that was when we were discussing DNA code and whether or not that shows that it's a good inference that we have an intelligent designer. So I think it is. And let me see if there's so many good comments, guys, but I really want to close this out because I've been going for a very long time. So I think, okay, Vesuvan says, I guess Dan is suggesting that the differences between mitochondrial DNA and human females shows that humans have been on the earth for a long time. Yes, that is what he is saying. And it's really debatable. I mean, I think actually the evidence points more toward a recent common ancestor, but I do, think we shouldn't be overly eager to, proclaim the younger timeline as true based on a few papers that might be in our favor. Just like I don't think evolutionists should cherry pick papers either and say that it supports the evolution timeline. So there's a variety of observations that we've made. And there's a variety of things that can affect mutation rates. We know that. So anyway, thank you everybody for watching. I appreciate all your support. I appreciate all the people who came on, and good night.